and good day everyone. So for this video, I will continue to discuss past year examination paper for MAT 435 Calculus for Engineers on chapter 2. So in chapter 2, we learned about indeterminate form and improper integral. So in this topic, we have two subtopics, L'Hopital's rule and limit of an indeterminate form, and also improper integral of unbounded interval. For the first one, we will discuss a paper on February 2022, question 2A, define two types of improper integral and its definitions. Okay, so to answer these questions, we need to write the definitions of improper integral. Okay, so for the first one, we have the improper integral of f over a until positive infinity is defined as integrations of fx function x dx from a until positive infinity equals to limit of b approaching to positive infinity a until b fx dx. Okay. For the second one, we have the improper integral of f over negative infinity until b is defined as, we have integral of function of f x dx, okay, from negative infinity until b equals to limit of a approach negative infinity, so from a to b fx dx. Okay, for the next question B, solve the improper integral of x over x squared plus 3 to the power of 4 dx from 1 until positive infinity. So the first step that we need to do is to write the definitions. So it is compulsory for us to write the definitions. Okay, so we write the integral back. X over x squared plus 3 to the power of 4 dx, okay, equals to limit of the approach to positive infinity. Okay, so x over x squared plus 3 to the power of 4 dx from 1 until t. Second step, we will solve the integral. So we have x over x squared plus 3 to the power of 4 dx. So in order for us to solve this integral, we need to apply u substitution. Okay, so apply u substitution. Okay, so we let u equals to x squared plus 3, and then we will differentiate du over dx equals to 2x, and then we make dx as our subject, because later we will substitute back into the integral. Right, so dx equals to du over 2x. Okay, so for the third step, Okay, we will substitute everything inside the integral. Okay, so we have x over x squared plus 3 to the power of 4 dx. So this one will be equals to integral of, okay, for the denominator parts, okay, we already let u equals to x squared plus 3. So this one will become u to the power of 4. And then, as we can see here, dx is equals to du over 2x. So this x will cancel the x on the numerator. So we have du here, and then we have 2. Okay, because we only cancel x, but we still have 2. So here will become 1. Okay, so next step, we take these 2 out. So we have 1 over 2, integration of 1 over u to the power of 4 du. And then we can bring u to the power of 4 up. So it becomes u to the power of negative 4 du. Okay, and then we can integrate, and it will become u to the power of negative 3 over negative 3. And then here we have plus c. Okay, so it becomes 1 over negative 6 u to the power of negative 3 plus c. And then don't forget, we need to substitute back our x squared plus 3. So it becomes negative 1 over 6 x squared plus 3 to the power of negative 3 plus c. Right? So for the fourth step, we write back our limit of t approach to infinity, 1 until t, x over x squared plus 3 to the power of 4 dx. And then on the right hand side, limit of t approach to infinity, we write down our solution just now, 1 over 6, 1 over x squared plus 3 power of 3 from 1 until t. Okay, now we will substitute the boundary here. Okay, first we will substitute the upper boundary. We have negative 1 over 6 bracket 1 over t squared plus 3 to the power of 3 minus the lower boundary. So minus will become plus 1 over 6 1 over 1 squared plus 3 to the power of 3. Okay, so t here will take positive infinity here. So 1 over positive infinity becomes 0. And then here, okay, the value will be 1 over 384. So this is the final answer. So this question consists of 8 marks, right? So next questions come from July 2022. Question 2a. Find limit of x approach to 0 cos 2x to the power of 1 over x. Okay. So to solve this question, first we need to let the value inside here. Okay, so first step, we will let y equals to cos 2x, because for these questions we cannot straightly evaluate the value of the limit. So in order for us to solve for this, we need to apply a method. So before we can apply the method, we need to let the function inside here to be y. Alright, so after that, after we let y equals to cos 2x to the power of 1 over x, we will apply natural log both sides. Okay, so we have natural log y on the left hand side and also on the right hand side. The reasons why we apply natural log is because we want to bring down the power here. Okay, so this one will become 1 over x natural log cos 2x. Okay. Alright, so second step, we bring back our limit just now. Limit of x approach to 0, natural log y equals to limit of x approach to 0, okay, natural log cos 2x over x. Okay, so when we substitute our limit here, x approach to 0, inside of this function, we will get 0 over 0. So we can apply L'Hopital's rule to solve this limit. Okay. Okay, so apply L'Hopital's rule. We get limit of x approach to 0. Okay, so we will differentiate numerator and also we will also differentiate the denominator x. So differentiate, we will get negative 2 sine 2x for the numerator and we get 1 for the denominator. Okay, so this one we need to multiply by because we need to differentiate inside of the natural log, so we will get 1 over cos 2x. Okay, alright, so therefore we get limit of x approach to 0, negative 2 sine 2x over cos 2x. Okay, so this one we substitute the limit. Okay, we substitute 0, we will get 0. Okay, we get 0 over 1 actually, so we get 0 as the answer. But this is not the final answer yet. Remember, this one is for natural log y. Okay, okay, not for the questions. Okay, so not solving the questions yet. We need to change it back. Okay, natural log y to become y. Right, so step 4, limit of x approach to 0. Just now, natural log y equals to this 0. Okay, so change back. So write down here. So we have limit of x approach to 0. So our y, okay, to get rid of the natural log, we will apply exponent both sides. So therefore, on the left hand side, the ln is gone, the natural log is gone. So we only left with y. And then on the right hand side, we will have limit of x approach to 0, exponent natural log y. Okay, so therefore our limit of x approach to 0 cos, okay, our functions from the questions, so write it back, will be equals to exponent 0, which also equals to 1. So this is our final answer. Okay, so for the final questions, we have July 2022b. Evaluate the improper integral of exponent 2x over exponent 2x plus 5 dx from 1 until positive infinity. So as usual, our first step, we need to write down the definition. Okay, so integrations of 1 until infinity exponent 2x over exponent 2x plus 5 dx equals to limit of b approach to infinity from 1 until b exponent 2x over exponent 2x plus 5 dx. Okay, so next step, we will solve the integral here. So we have integrations of exponent 2x divided by exponent 2x plus 5 dx. So this one we cannot straightly integrate, therefore we need to apply u substitution. So u will become exponent 2x plus 5. Okay, so differentiate, we get 2 exponent 2x. So change the form here, dx equals to du over 2 exponent 2x. So third step, substitute everything in terms of u. Okay, so for the denominator part, we have u, and then here dx will become du over 2 exponent 2x here. So this exponent 2x will cancel exponent 2x on the numerator. So therefore, we only have 1 here, multiplied by du, and then we still have our 2 here. Okay, so we have 1 over 2, okay, integral of u to the power, 1 over u du. So now we can integrate. So we have 1 over 2 natural log u plus c. Okay, and then we need to substitute back our u. So 1 over 2 natural log exponent 2x plus 5 plus c. Okay, so fourth step here, write back our limit of b approach to infinity exponent 2x over exponent 2x plus 5 dx equals to limit of b approach to, we have our integral here from 1 until b. Okay, so we have integral of 1 until b. Our solution just now, so here we do not have the integral anymore because we already solved, okay, the integrations. So we have bracket. Okay, so the answer 1 over 2 natural log exponent 2x plus 5. So no more plus c because we have the boundary here from 1 until b. So substitute. Okay, so limit here we have infinity. So limit of b approach to infinity. Okay, so for the first part, we will substitute the upper boundary. So we have 1 over 2 natural log exponent 2b plus 5 minus the lower boundary, we have 1 over 2, okay, natural log exponent 2 multiplied by x, we multiplied by 1, we get 2, so plus 5. Okay, so evaluate this one, we will get here this part we will get infinity, so this part we will get infinity minus value here. So we still will get infinity as our final answer. Okay, so I think that's all for chapter 2. I will continue to post video on chapter 3 after this. Bye.